Since quadratics are not one-to-one function, meaning they don't pass the horizontal line test, a horizontal line will touch at 2 points. So the inverse is not going to be a function, therefore it's not one-to-one. In order to find the inverse function, we need to restrict the domain. Meaning we're only going to take part of the function and find the inverse of only part of the function. We're only going to look at the part of the graph that will be one-to-one. For example, let's make the quadratic to the right one-to-one. We need to restrict the domain so that we are only looking at the right or left half of the parabola. Basically, we split it right down the middle, and we either look at the right or the left, right? Left or right. Okay, so the vertex, when we look at the vertex, that we call that h comma k, the right half will be the part that's where the x values are greater than or equal to h, and the left half would be less than or equal to h. So your h value is the x value of the vertex. The vertex form of a quadratic function is f of x equals a x minus h squared plus k, where h and k is the vertex. So h is going to be the center of the parabola. It's right in the middle. It's right where the axis of symmetry goes through the parabola. So does it matter if we take the left or right half of the quadratic? No, it really doesn't. You can pick whichever side you want, left or right, although if you think about it, when you take the square root of something, most people will say the square root of 4 would equal 2. Because most people think of 2 times 2 equaling 4 and forget that, well, negative 2 squared is also 4. So technically the square root of 4 could be 2 or it could be negative 2. It's just more common to say it's positive 2. So does it matter if we take the right or left half of the quadratic? No, but it's more traditional to take the positive. So more often than not, we'll use the positive or right half. Because it's more traditional and we have more application for taking the square root and having a positive outcome. Okay, so the steps for finding the inverse of a quadratic. First, we're going to restrict the domain to the right-hand half, just so we always do it the same way. So all x values will be greater than or equal to h, whatever our h value is. That'll be the restriction. We're going to switch our x's and y's. We're going to get the y alone. We're going to take the square root. Oh, the positive square root, the positive. Since we restrict the domain to the right-hand side of the parabola, then we get y by itself and rename y to f inverse of x. All right, let's try some examples here. So let's see, we switch f of x to y. Okay, next we're going to switch our x and y. Okay, now we need to get the y out of that parentheses, so I take the square root of both sides. And I'm not going to do the plus and minus. I'm only going to take the positive square root. So now we have the square root of x equals y plus 2. We take away 2 on both sides. So y equals the square root of x, take away 2. And now we change y to f inverse of x. The 2 is outside or after the square root. The square root is only covering the x on this problem. All right, let's try another one. Okay, first we switch our fx to y. We're going to change our x and y, swap places. Okay, we want to get this quadratic portion by itself. We want to get this part by itself before we take the square root. So I'm going to take care of the adding and subtracting first, then the multiplying and dividing next, before I take the square root. So we're going to add 4 to both sides. So we have x plus 4 equals 2 times y minus 3 squared. Now we're going to divide both sides by 2. So we have x plus 4 divided by 2 equals y minus 3 squared. We're going to take the square root of both sides. So let's see, that gives us y minus 3 equals the square root of x plus 4 over 2. And that square root needs to cover the whole fraction. It's not just over the top. Make sure that square root is over the entire fraction. The x plus 4 over 2. All of that is in the square root. Okay, we're almost there. We just need to get y by itself. So we're going to add 3. We're going to add 3. Now this 3 comes after the square root. It's not under the square root. All right, now y is by itself, and we can write it as f inverse of x. Let's see, I'm out of room. I'm going to write it right up here. So the inverse would be f inverse of x would be, that's the same thing as y, equals the square root of x plus 4 over 2 plus 3 goes after. There we go. All right, let's do a couple more. Okay, I'm just going to go ahead and switch my x's and y's. This will be x equals y minus 7 squared plus 9. So the fx becomes y, and then we switch x and y. We're trying to get this quadratic portion by itself before we take the square root. So I'm going to take away 9 on both sides. We have x take away 9 equals y minus 7 squared. Now that the quadratic part, the part with the square on it, is isolated, now we can take the square root of both sides. So y take away 7 is equal to the square root of x minus 9. We can add 7 to both sides. So then our y is by itself, and we can change it to f inverse of x equals the square root of x take away 9 plus 7. All right, last one. Switch your x and your y. Again, we want to get the quadratic portion by itself first before we take the square root. So we divide both sides by 3. So x divided by 3 is equal to 2y take away 5 squared. We take the square root, make sure the x and the 3 are both under the square root. That whole fraction is being square rooted. Square root both sides. So now we have 2y minus 5 equals the square root of x divided by 3. We're going to add 5. So 2y 2y is equal to the square root of x divided by 3 plus 5. Now we're going to divide by 2, and y is by itself. So we have f inverse of x is equal to the square root of x divided by 3 plus 5 all over 2.